Good morning, students. How are you today? How was your weekend? I thank God I'm back and better. Thank God for the gift of life, and I want to thank you. I appreciate you all for your prayers. May God continue to be with each and every one of us. Thank you so much. Today we are going to continue from where we stopped, which is the next theorem, which says that the tangents to a circle from external points are equal. What do I mean by that? Now, in last class we talked about this theorem, that is the center of a circle, that is the radius from the center of a circle to the tangent, forms 90 degrees, that is perpendicular. So today we are going to look at this theorem, which states that the tangent to a circle from external points are equal. Now, what do we mean by tangent to a circle from external points? If I have a circle, let's say this is a circle, and I have a tangent. This is a tangent. Can you see? And there is another tangent at this external point. So if I connect this line together, I have tangents. Now, from the center of this circle to that point of contact on the circumference, the tangent, and another one from here to here, I'm going to have the radius, that is from the center to circumference, center to circumference. You can see I have this, let's say this is A and this is B. OA is equals to OB. Now, my theorem is saying that my what? TA is same thing as TB. That is the external line here, which is the tangent, they are what? They are equal. Now, for me to know that they are equal, if I do a little construction, from here, I know that from here like this is 90 degrees. That is radius perpendicular to tangent. This is also 90 degrees. So if I do a little construction, let me connect this line to T. So if I connect this line to T, you can see I have two right angle triangles there. And this line OT is the same thing for this triangle, and it's also the same thing for this triangle. So because OA and OA is equals to OB, they are what? Radii. That is radius. When you have two radius, we call it radii. So the next thing, I know that this angle TAO, that is a right angle, is 90 degrees, and this one is also a right degree. And I know that OT is connecting this triangle together. This OT, line OT, is collecting this, is the same thing with this triangle, and it's also the same thing with this triangle. So I join OT. That's the construction. I join OT. So if that is the same, that means this angle here, this line here, BT, is going to be the same thing as what? The line AT. So that is why we call it tangent. So meaning that the external point here, if from here to here is 10, from here to here is also what? 10. That is what that theorem is saying. Do you get that now? So let's take a sample to explain better. Another thing, I can draw a line to this. So if I draw a line, you can see I form, this is a center. I form another isosceles triangle here. So, and if you look at this place is going to be right angle. This place is going to right angle. So this is the same. And from here to here is same thing as from here to here. Do you get that now? Because of that line that I joined. So let's take a sample and explain better.